This video talks about the cardiac and the vascular function curves, and this is my best effort to make things a little simpler. Essentially, this is a very simple physiology graph, but sometimes with the two lines crossing each other can be a little bit confusing. So this is my best effort to make things simple. So let's first talk about what we have in the x-axis and what we have in the y-axis. On the x-axis, we have right atrial pressure or end diastolic volume, or another name for end diastolic volume is going to be preload. So on our right axis, we have right atrial pressure or end diastolic volume. On the y-axis, generally we have cardiac output and venous return. So which graph is cardiac output? Which graph is venous return, right? So in this cardiac vascular curves, the one that's starting from the zero axis going up, this is going to be our cardiac output. And the graph which is starting way above on the y-axis and coming down and meeting the x-axis, this is going to be our venous return. Now, if we are asked in this particular graph that which is our right atrial pressure, so what is the right atrial pressure for this particular graph, what would be your response? The right atrial pressure for this particular graph is when the cardiac output meets venous return. And so what is that? So this is the point where cardiac output and right atrial pressure meets each other. So we are going to draw a line straight down and find out that what is this value. Let's say this value is 5, and so 5 on the x-axis. So that is going to be our right atrial pressure. So in this particular scenario, the right atrial pressure is going to be 5. Now let me ask you another question. What would be the mean systemic pressure? So in this graph, the mean systemic pressure is when the venous return graph intercepts the x-axis. So this particular level right here is going to be our mean systemic pressure. So let's say that pressure is going to be 10. So the mean systemic pressure is going to be 10. So now that we understand the basic premise of this graph, let's see how it really applies to physiology or pathophysiology. So if we call this point, or if we call this scenario of cardiac output and venous return to be normal, what is going to be what's going to happen to this graph when a person is exercising? So when we are exercising, what's going to happen to our cardiac output? Our cardiac output is going to be up, right? What's going to happen to our venous return? Okay, so let's think about what about total peripheral resistance. The total peripheral resistance is going to go down. Why is that? Because we need more blood to go to the heart. As a result, it's going to vasodilate and our total peripheral resistance is going to go down. As a result, because of increased cardiac output, our venous return is also going to go up, right? So let's see the graph now. The blue line here is our cardiac output. The cardiac output is going to go up. Hence, we see that the cardiac output is the green line, which is going up right here. So our cardiac output is going to go up. And what about venous return? This blue line coming down was our original normal venous return. But since we're exercising, our venous return is also going to go up. But our total peripheral resistance is coming down. So don't confuse, just because the total peripheral resistance is going to go down, our venous return is also going to go down. Our venous return is going to go up. So now you see that our normal has kind of shifted upwards. So this is going to be the scenario when we are going to be exercising. Our both cardiac output and our venous return is going to go up. So now let me ask you, see our normal moved exactly up, right, vertically, right here. What scenario are we going to see when our normal is going to come exactly down? Meaning our cardiac output is going to drop and our venous return is also going to drop. What kind of scenario are we going to see this in? This kind of scenarios are usually seen in places where we're having hemorrhage, okay? So what happens in hemorrhage? Our TPR goes up, Why? Because we want to minimize our hemorrhage. As a result, we're going to have vasoconstriction of the vessels. As a result, our TPR is going to go up, and our cardiac output is going to drop because we have less blood going to our heart. Our venous return is also going to drop because we have less blood in our system. As a result, the curve, both the cardiac output and the venous return, is going to drop, and we're going to be here, exactly vertically down from our normal position. So these are the two scenarios where we see both the cardiac output and the venous return going in the same direction. Either they're both going up or they're both going down. What if I say one stays the same and the other changes? What kind of scenarios do we see in these kind of graphs when we have one variable changing and the other staying constant? So the one example that's coming to my mind instantly is heart failure. What happens in heart failure? What's going to happen to our cardiac output in our heart failure? The cardiac output is going to drop because our heart is failing, right? What's going to happen to our venous return? Our venous return is going to stay normal because nothing is wrong with our veins. It's just the heart is failing. So what's going to happen to our curve? So let's start with our original graph. So this was our cardiac output. Now the cardiac output is going to drop. So let's say this blue line here is our dropped cardiac output. So we know that our cardiac output is dropping, but what's happening to our venous return? Our venous return is staying the same. So which is our venous return? This one, this original graph. So that's going to stay the same. So where is it intercepting with our cardiac output? Right here, you see? So this is going to be the position of the heart, or the cardiac output, venous return, right atrial pressure when our heart is failing. So now let's do a quick review. Now if I ask you what's going to be the right atrial pressure for this failing heart, let's see. I'm going to draw a line right here. Let's call this number 7, okay, or 6, more like a 6. So our right atrial pressure is going to be 6. What's going to be our mean systemic pressure? Our mean systemic pressure is going to remain the same. It's going to be 10. What's going to be our cardiac output? It's going to be the one that dropped here. So, sorry, here. So this is going to be our cardiac output, and the venous return is the same as our original graph, which is the normal.